This video will briefly introduce a broadband dual-polarized single-layer reflectarray antenna with independently controllable 1-bit dual beams. The relevant work can be found in IEEE transaction antennas and propagation. The millimeter wave communication systems usually require independently controlled multiple beams, high isolation, and high gain. One possible scheme is designing a dual-polarized dual-beam reflectarray antenna to satisfy the requirement. But realizing independently controllable dual-polarized antenna, both for single-layer structure and broadband width, is challenging. This work creates the magnetic resonance and the electric resonance structure for 1-bit phase compensation to alleviate the challenge. Following are some details. The first is the 1-bit unit cell design. State 0 of the unit cell act as a magnetic wall, which provides a 0-degree reflective phase. And state 1 of the unit cell works as an electric wall, which provides a 180-degree reflective phase. Second, we analyze and optimize the parameters of the unit cell. The frequencies of magnetic resonance and the electric resonance can close enough if the size of the patch and slot are suitably chosen. So, the 1-bit phase compensation can be achieved when switching the two states. Meanwhile, the trends of the reflective phase for the two states against the frequency are similar, which brings a wide working bandwidth. And the high isolations between two polarizations ensure independent dual polarization control. Third, to design two separate beam directions for two polarizations, the phase distribution on the surface can be calculated. So, the states of unit cells can be determined. We then design and fabricate a reflectarray based on the proposed unit cell. It can realize 20-degree beam direction for horizontal polarized incident waves and -15-degree beam direction for vertical polarized incident waves. More details of the work can be found in the reference. Thank you for your attention.
In the ESA project called MARTA, multiple beam antennas using reflectarrays and transmittarrays, the goal was to reduce the number of antennas in the satellites that provide broadband internet access. For example, to have internet in the airplanes. Nowadays, these satellites use 4 reflector antennas of 2 meters that generates about 100 beams. Each beam is alternating in 2 frequencies and 2 polarizations to minimize the interference. In this project, we have demonstrated that the complete coverage can be achieved with only 2 reflectarray antennas instead of 4 reflectors, where each reflectarray generates twice the number of beams that a conventional reflector. This is a model of the real antenna scaling a factor of 2 that proves the concept.
This is a parabolic reflectarray designed to generate multiple beams in transmission and reception from a geostationary satellite. The reflecting surface is formed by an array of more than 15,000 printed elements. The dimensions and orientation of the elements have been carefully optimized to deviate in opposite directions each circular polarization received from the feeds. This is a unique property of reflectarrays. Then, 2 beams are generated in orthogonal polarizations for each feed, so the number of antennas and feeds in the satellite can be reduced to the half, with a significant reduction of mass and volume of the payload.
In this video, I will briefly introduce the light-controlled, large-scale, wirelessly reconfigurable microstrip reflectarrays. Pin diode is one of components used to design reconfigurable reflectarrays with massive wires. However, massive wires cause 3 limitations, including the highest directivity, the upper operating frequency, and the number of independently polarizations, because they all need more biasing wires. However, the element spacing is not large enough to place more wires. Therefore, our objective is to remove the wires. for large-scale, wirelessly reconfigurable microstrip reflector arrays. Light is used to transmit control signals instead of conducting wires. Therefore, no wire routing issue on the array. Pin diode and photodiodes are integrated on the element with low biasing voltage. Then, let's get to the design of a 1-bit light-controlled reconfigurable elements. The element is controlled by switching pin diode states, and the pin diode is controlled by light-sensitive photodiode. When the light is on, the pin diode is in on state, can be thought as short circuit. When the light is off, the pin diode is in off state, can be thought as open circuit. At 10 GHz, the phase difference between two states is 180 degrees, the same as desired. Using the element, a 1024 element array is designed. The array achieves 120 degrees beam steering range. Therefore, the light-controlled concept is validated in simulation. In experiment, part of elements are fabricated and measured. A Vivaldi antenna is designed as feed. A light control system consisting of laser emitters is designed. By controlling the states of each emitters, the array achieves beam steering from 30 degrees to 45 degrees. In conclusion, the concept of light-controlled beam steering antenna array has been proposed and validated. With the combination of pin diodes and photodiodes, the proposed method paves the way for developing reconfigurable reflector arrays of higher directivity and more polarizations at higher frequency. Thank you for watching.